Hi, welcome to Chem 110's experiment number 5. In this lab we take copper sulfate, pentahydrate, and reduce the copper from the copper 2 plus ions to copper metal, and we then collect that copper metal and compare the mass or moles of copper that we generated to the copper sulfate we started with. So on the first page of the lab packet we've got the reaction written out there. It's kind of a fun reaction because it's colorful, but what we're doing is taking copper sulfate, we're letting that combine with a readily oxidizable metal. In the experiment we do at school we use zinc, though today I'm going to try doing it with magnesium and see if that works. And ultimately what happens is we form copper metal. So we're also of course going to have the leftover aqueous zinc sulfate that gets washed away and the water that is locked into the crystal there of the copper sulfate. Okay, so first thing we do is we measure out a certain amount of the copper sulfate. So here's some data there, I'll put it back up in a minute, but we're going to start with the difference in these will be the amount of copper sulfate that we're going to dissolve in water, and then ultimately we'll figure out how much copper we produced from some of these other numbers, and we'll come back to that. So here's my blue solution of copper sulfate. To that I'm going to add my metallic magnesium, and I don't know if we can see this. Yeah, let's put some more in there. Starting to, might be able to see the small particles kind of floating around, these little black and brown things swinging by. Those are chunks of copper that are forming and then breaking free of the pieces of magnesium. The magnesium is rising and falling because it's also undergoing some oxidation of water. It's producing hydrogen gas there. All right, so we'll let that go for a little bit. Now when the solution is completely clear, that tells us that the copper has been completely reduced to the copper metal. At this point we have solid copper and the leftover magnesium or zinc, whatever we used, in the bottom. And to get rid of the unwanted metal, we put in some acid, and that acid will result in the zinc or the magnesium being oxidized, but because copper is much more difficult to oxidize, it will remain in solution. So we'll start to see the bubbles of hydrogen gas coming up as that magnesium is consumed by the acid. And we can speed this process up. If we have tweezers available, we can scoop out the pieces of unreacted magnesium metal, rinse them off so that we don't lose any of our product. And this really just speeds up the process. All of it would eventually dissolve. All right, once we're happy that we've got all of the magnesium out, the only metal left is the copper. And then we'll go and we'll just filter this. There's a little bit left in there. And we'll filter this and collect the copper in a final weighing. In the lab, we filter in filter paper and put in the oven to dry for the next lab period, and then we come back and weigh that completely dry product and observe what its appearance is. So day 2, we weigh our product and we say that the product in the filter paper and the beaker that it was originally weighed in is 63.38 grams. We had that the filter paper with the beaker was 63.1. So again, that'll be our difference. This difference rather will be our mass of copper. All right, so switch into the calculation page. I don't want to do all the work, but when we play with those numbers, we should come up with a mass of copper sulfate that's going to be 1.1 grams. So go ahead on your sheets and actually fill in what the numbers are, and hopefully you come up with the same number I did. Likewise, the mass of copper, show your work. How did we get the 0.27 grams? And then the calculations that are a little more germane to what we need to do. This first percent copper in copper sulfate is the experimental percent copper. So we really need to define our equations here, our terms, and this percent copper is going to be defined as the mass of copper we recovered divided by the mass of the copper sulfate pentahydrate that we started with. And so work those out, it's just the ratio of those previous two numbers, multiply by 100, and that's our percent. And somewhere in the neighborhood of 25% by mass. Okay, the next one down is the theoretical percentage. This is based on the formulas. So if we look at the copper sulfate pentahydrate, we have 1 copper atom for every sulfur, 4 oxygens. We have to include the water, so we have 10 hydrogens and 5 more oxygens. So again, writing out the general equation, it'll be the atomic mass of copper, or the copper that's in that formula, divided by the entire formula mass. A copper, a sulfur, 4 oxygens, 10 hydrogens, and another oxygen. And so when we work that out from the periodic table, we'll get another percentage, and again, somewhere in the neighborhood of 25%. And lastly, we're going to calculate the experimental error, which is going to be defined, again, write this down, as the experimental percentage minus the theoretical percentage. Take that difference, divide it by the theoretical percentage, multiply by 100. And hopefully this is a small number. That just depends on the actual data that you get to work out. Okay, as part of the... I think I misspoke above. Make sure in the denominator here for the formula mass, it's copper, a sulfur, 4 oxygens, 10 hydrogens, and 5 more oxygens. I think I said 1 before. All right, so that was the calculations. With this lab, we're also supposed to draw a graph and hopefully talk about that graph. And here's some of your classroom or classmates' data. So just initials of everybody. There's Marty. He had 3¼ grams of copper sulfate and produced 0.91 grams of copper. So what we want to do with all this is build a graph that's going to be grams or mass of the copper sulfate pentahydrate as your independent variable, and the grams of copper produced, and whatever those graph points give you, describe how that works. And what we like you to do is take your data, which was the one that we did all the lab work with, and make a specific mention of where that is in the graph. All right, that'll be it. Thanks.